Hello guys, this is Mr. Campo and today's lecture will be about linear equations, linear inequalities, and simultaneous equations. Let's type that here. Linear, my fingers are frozen. Linear equations, linear inequalities, and simultaneous equations, simultaneous equations. So you probably know these already, but if you do not, this will be a good review for you guys. I apologize. It's very cold here in Wuxi, and anyway, my hands are frozen. Let's get let's get started. So remember, right? What do you have? How do you solve these? What color should we use? Black. Okay. Remember, whatever you do to one side of the equation, you must do to the other side, right? So you must keep it balanced. Keep your equation balanced. Again, what do I mean by that? If you add a number to one side of the equation, you have to add the same number to the other side. If you subtract, you have to subtract. If you multiply, you have to multiply everything on both sides of the equal sign. This is the equal sign right here. This equals equal sign. All right. And remember, um, to undo, to isolate the variable and to undo an operation, you must do the opposite. What's the opposite of addition? Subtraction, right? And the opposite of subtraction? Addition. What's the opposite of multiplication? Division. And the opposite of division? Multiplication. So this is something you have to keep in mind as you solve your equation. You have to undo some of the operations being performed on the variable. And if there's something being added, you have to subtract it. Something being subtracted, you have to add it, and so on. To isolate. Our goal, let's write it right here, note. Our goal is to isolate. You want to remember this word. Isolate. This is a no. Our variable, whether it's x, p, y, t, any variable, okay, or pronumeral, same thing. All right, let's do some examples. Example 1. 4x minus 3 times 2x plus 5 equals to 3 times x minus 2. All right, so we have to isolate our x, but we're gonna have to multiply all of this out and then combine like terms, combine like terms. And then again, isolate the variable. So we can start by getting rid of this parenthesis, these two parentheses. How do you say parentheses? The plural of parentheses. Parentheses? I actually don't know. So no. Parentheses. That's a good question. So yeah, we gotta get rid of the parentheses. This one and this one. So we're gonna multiply, right? We're gonna distribute that number 3. These two number 3's. So we get 4x minus 3 times 2x is 6x. Minus, right? Negative 3 times 5 is negative 15 equals to 3 times x, 3x. And 3 times negative 2 is negative 6. Now we're going to combine like terms. So we have these 4x and negative 6x. That becomes negative 2x, negative 15, and then 3x minus 6. That's all we can combine for now. Now we want to isolate our variable, right? So you want to have your variables on one side, this way. Variables, and the other side you want your numbers. All right, so I'm going to bring this here. So I'm going to subtract 3x from both sides. And I'm going to take this 15 and I'm going to send it to the other side. So I'm going to add so this becomes negative 5x. This becomes 0. There's no need to write this 0, so we can just write the equal sign. These two become 0, and then we have negative 6 and positive 15, so that's going to be positive 9. And now this negative 5 is multiplying the x, so we divide by negative 5, right? So this becomes x equals to 9 over negative 5. And that's it. That would be the answer. Well, you can go ahead and simplify this because this is an improper fraction. So you can go ahead and divide 9 divided by negative 5 equals to negative 1.8. And that's the final answer, okay? Now, if you want to double check your answer, you take this value and you plug it in the original equation. If you get a true statement on both sides of the true statement on this side and true statement on this side, the same statement, then your answer, this one, it's okay, it's correct. If you get different numbers, then you got to check your steps, okay? All right. Let's do another one. Number 3. 4 divided by 2x minus 1 equals to 3 over x plus 7. So first we're going to have to combine these expressions, these terms, because we need to isolate our x. So first we're going to have to bring all of this to the numerators. To the numerators. So we're going to have to multiply. We can multiply this. Well, it's also called cross multiplying. For example, if you have a over b equals to c over d, so you can cross multiply, right? And then you get a times z equals to b times c, cross multiplying. So, all right, so if we cross multiply this, come on, why is it closing? We're going to get 4 times x plus 7 equals to 3 times 2x minus 1. Then we go ahead and distribute these numbers, so it'll be 4x plus 28 equals to 6x, 3 times 2x minus 3 times negative 1 is 3. Now we can combine the like term. We can combine like terms. So in this case, I'm gonna bring my 4x here to the right hand side, and I'm gonna bring my numbers, all my numbers, on the left hand side. These two cancel out. This becomes 31. These two cancel each other out, become 0, and then we have 6x minus 4x equals to 2x. Now I can just divide everything by 2, and I'll get x equals to 31 over 2, right? And that's 15.5. And that's it. That would be the final answer for that. Okay, so easy, right? Easy stuff. Let's do this number 4 we have here. Example number 4. We got this square root of 2 minus x equals to 3. So what operation can we perform to get rid of that square root? We can square everything, right? Because this is the same as um, 2 minus x to the 1/2. So if I square this, you see how these two will cancel each other? Well, they'll become 1, not cancel each other out. If you multiply 2 times 1/2, you get 1. And that's what I need to do. I need this exponent to become 1. So I'm just going to raise everything to the second power, and I have to do the same to the other side of the equation. So these two will become 1, and then we have 2 minus x equals to 3 squared, which is not 3 squared, which is 9. And now it's just a matter of rearranging the expression. I can just subtract 2. This becomes 0, and then we get negative x equals to 9 minus 2 equals to 7. Then we divide by negative 1, and we get x equals to negative 7. All right? Easy, right? Okay, now we're going to get into linear inequalities. Linear inequalities, okay? So let's see. For these, after you get the solution, you have to graph a number line. You have to graph the solution on a number line. What do I mean by that? Well, something like this. This would be our number line. And then let's say, I don't know, it says that x is greater than or equal to 1. So we find our 1 here. And then this it says equal, so we're going to draw a circle. We're going to fill it in because number 1 is included. And then it says greater than or equal to 1, so we have to go to the right, towards the right of the number line. And all these values would be the solution for this inequality, okay? And that's what we need to do when we solve these linear inequalities, okay? At the end, you have to do a number line, okay? So let's see, let's solve them. Now, one thing we have to remember, the main thing, you solve them, let's type this. Solve them as a regular equation. You follow the same steps. However, there's one step you have to do differently. If you divide or multiply by a negative number, what happens? The inequality sign direction, the direction of the inequality sign has to change. The direction of the inequality sign will change. What do I mean by that? Well, let's say this example, negative 2x greater than 4, right? So to isolate my x, I have to divide by negative 2. If I go ahead and do that, you see, look at this step. If you divide or multiply by a negative number, the direction of the inequality sign will change. So I'm going to have to change this. So it's going to be x being less than, okay, instead of greater, less than 4 over negative 2. And then this simplifies to 2x being less than negative 2. All right, that's what I mean by the direction of the inequality changing, okay? That's the only thing you have to keep in mind. And everything else you can just do as a regular equation, all right? So let's do some examples. We have 12 minus 3x greater than 2 plus 5x. Again, we just look at it as a regular equation. We follow those steps. If we encounter that we have to divide or multiply by a negative number, then you have to change the inequality, the direction of the inequality sign. So again, we have to group all your x's on one side and all your numbers on the other side. So I'm gonna send my, let me see, my x's, my prenumerals, my x variables, I'm gonna send them to the right. So I'm gonna do plus 3x, I meant to say 3x. These two I need to send to the other side, so I'm gonna subtract. Okay, 12 minus 2 is 10. These two become 0. These two become 0, and then I get 8 times x. Now I need to divide by 8, right, to isolate my x. And this becomes 5/4. X is greater than 5/4. 5/4, 5/4. All right. Okay. Nice. Let's do another one. Number 2. You got 1 minus 2x divided by 4 greater than or equal to 2 times 1 minus x divided by 3. We can cross multiply this and we should get 3 times 1 minus 2x greater than or equal to, this 4 we multiply, right? So it will be 8, right? 4 times 2 is 8 times 1 minus x. And then we just distribute these numbers. So we get 3 times 1 is 3. 3 times negative 2x is negative 6x. And then we get 8 times 1 is 8 minus 8. Well, 8 times negative x will be negative 8x. All right, I'm gonna put all my x values on this side. So I'm gonna add 8x. And I'm gonna send my numbers to this side, to the right-hand side. So I'm gonna subtract. This becomes 0, this becomes 2x, right? Greater than or equal to, did I put the inequality? I missed the inequality sign, right? I mean, I didn't write it, sorry. Okay. All right, 8 minus 3, come on, this thing is closing on me, why? 8 minus 3 is 5. And then these two become 0. And now I just have to multiply, divide everything by 2. And I get x greater than or equal to 5 divided by 2. 2.5, right? And that's it. Okay, we're gonna move on. Oh, I'm sorry. I forgot. We have to draw the answers, right? I said it, I mentioned it before we started this, but we didn't write them. Let's see. So you have to write this, you have to show the answer on a number, on a number line. So you want to draw your number line like this. Draw some arrows at the ends, indicating that it's going in both ways, both directions. We locate our number, right? 5/4. So 0 here, 5/4 approximately around here, and then it says x is greater than. I'm sorry, x is less than, not greater. Yeah, x is less than 5/4. So it's not included, so we draw an empty circle like this, and then if it's less, it's gonna go to the left, towards the left. So let's see, and that's it. This will be the solution for that. Okay. Our next one, x is greater than or equal to 2.5. So let's see. Number line here, locate 2.5. Okay, 0 approximately here, 2.5. And then it is included, so we're going to do a circle is going to be filled in. And the numbers are going to be greater, so our arrow is going to go to the right. Okay? No, undo that. I don't need that. This one. All right, guys. So that's how you solve these linear inequalities, okay? Let's see. We're going to change the subject now of the equation, okay? Changing the subject. Not changing the subject of the conversation, but of the formula. In other words, isolating the other variable. That's all. So if you have two variables, they may give you the equation with one of the variables isolated, and they may ask you to isolate the other variable. So let's see. We got this y equals to 7 minus 3x. And they may ask you to change the subject to the variable indicated in the parentheses. So to the variable x, so we have to isolate x. That's it. So we can start by subtracting 7. So we're going to get y minus 7 equals to negative 3x. And then we can divide by negative 3, right? So we get y minus 7 divided by negative 3 equals to x. And that's it. Our x is isolated. We change the subject of the formula from y to x. Pretty easy, right? Let's do another one. Say t equals to 2 pi times L over G. And they want you to change the subject of the formula to G. So we want to isolate our G, right? We have a square root here. We can start by squaring everything, right? We can square everything. So if we do that, we're going to get t squared equals to 4 pi squared times L over G. This is an L. When you square, let me do it here. Square, square, square. Okay? Remember, whatever you do to one side of the equation, you have to do to everything. So if we square this will get rid of the radical sign, but we also have to do it to this, and it's gonna become 4 pi square. My bad, pi square here, and then t square. Okay. Now we can divide by 4 pi, right? So we get t square divided by 4 pi square. I meant to say 4 pi square equals to this. And we need to isolate that G. So we just need to cross multiply and isolate our G. Or you can use different ways to do this. You can cross multiply. Well, let's do it that way, right? It'll be G times T squared equals to L times uh, 4 pi squared. And then what we need to do is divide by T squared, right? So we get L times 4 pi squared divided by T squared, right? And that would be the final answer for that. Okay, we change the subject of the formula to G, okay? To G. So we just isolated G. Okay. Okay. Lastly, let me do this one is a little more complicated. Let's do it. It takes more steps to do. We got m equals to x plus 3 over x plus 1. And then one you do, I change the formula to x. Change the subject of the formula to x. So we cross multiply and we get mx plus 1 equals to x plus 3. We're going to multiply these terms. So we get mx plus m equals to x plus 3. Now what I want to do is I want to group the terms with an x so that I can factor out the x, right? Again, grouped the terms having an x so I can factor out the x. So I can bring this x here and I can send this m to the other side, right? So I can do minus m. So it'll be minus m here, and then I can subtract this x. I need more space. Let's see if I can, no, okay. So I'm gonna have to, all right, let's do it right here small. So these two cancel each other out and I get mx, sorry about that, mx minus x equals, I'm all the way at the bottom of the page, so equals to, these two will cancel out and then we get 3 minus m, right? Now I'm gonna bring this to the right hand side of my screen so you guys can see what I'm gonna do next. I'm gonna factor out the x, so x times m, right? X times m, it'll give me mx, and then x times negative 1 will give me negative x, right? And then equals to 3 minus m. And now I need to divide by m minus 1, right? And then these will cancel, become 1, and then I'll get x equals to 3 minus m over m minus 1. And that's it. We changed the subject of the formula to x. This one took a few more steps, but same principle, all right? Lastly, simultaneous equations. So I'm going to stop right now. This is part 1. Or in part 2, I'm going to do simultaneous equations, okay? Part 2, we're going to do simultaneous equations. Excuse me, and word problems. All right, so I'll see you in part 2, okay? Bye-bye.